Good time. Why is that not letting me do that? Okay. I don't know if this preamble is any good to you until we actually get going. So here's the thing, is you've got to solve the trig equation. So in 4.5, I gave you trig equations that had already been solved. Like example A is already been solved. You just need to go ahead and do the theta part of it. But now what we're going to do is we're going to add a new layer to it where you actually have to solve the equation. So there'll be some factoring. So dig deep for grade 10. And then you're going to have some multiple answers. And I appreciate the look, Jacob. So what we're doing is we're taking 4.5 and we're giving you an equation. You're going to solve the equation, then you're going to do 4.5 stuff on it. Okay, so we're building on top of it. So a couple of quick things. If there's a trig function that is squared, so if you have tan squared theta, if that's in there anywhere, you're going to bring them all to one side and factor like a trinomial. Be aware of the given interval. So those are the restrictions. And your restriction will tell you whether you're in degrees or radians. That's 4.5 stuff. Identify whether the trig function is positive or negative to determine what quadrants your answer will be in. And there will often be multiple answers, okay? So that's 4.5, but we're adding the solving. So let's go to sine of 1/2. And that's a nice easy one. This is 4.5. We're going to start off with 4.5. And let's change that restriction to something more exciting. Let's change that 0 to -3 pi. That's exciting. Okay, so we're looking for exact values in this. So the nice thing about this is all those exact values are going to be on the unit circle, right? They're all going to be there. So sine of 1/2. Sine theta of 1/2. So where on your unit circle is sine going to be positive? 1 and 2. So sine is positive in quadrants 1 and 2. And I find it helpful to write that down. You do not have to write that down if you don't want to. So using your unit circle, where is sine 1/2? A positive 1/2. Okay, so we got theta is equal to pi over 6 and 5 pi over 6. Hey, look at us. We just did our positive rotation. We just did this one here. All right, so we know, I don't even know where I was writing on it. Oh, here it is. You'll see a lot of my scrap paper is all just unit circles. So we have an answer here and we have an answer here. Okay, now if we're going -3 pi, -3 pi. So that's definitely once around in the negative direction. So once around in the negative direction is -2 pi. So let's do those ones first. Like always break it down into your rotations because this will help. So -2 pi, how many answers am I going to have? I'm going to have 2. So really all we have to do here and here is find the negative coterminal angles. Kind of looks like a frog. So we're going to have, in the negative rotation, I should have I was going to do 11 pi over 6, and this one's going to be -7 pi over 6. So that's the negative coterminal angle for that one, and that's the negative coterminal angle for that one. Okay, pretty straightforward. We're going to go back to this. So we went all the way around once in the opposite direction. And now I'm going, how many more pi's? Just 1, so that's going to be here. Am I going to have any answers in here? No. So are there any additional answers? No. Done. Woo! Look at us. Okay, so now we're moving into 4.6. So now we're going to solve this. All right. Now I'm going to grab another scrap piece of paper because that's the story of my life. So we have sine squared theta minus sine theta equals 0. And we'll just do it over a nice restriction as we start, just so this one might look a little odd to you, but what if I said let sine theta equal x? Would you know how to deal with that? Common factoring. What am I going to common factor out? I'm going to take out an x. What am I left with? X minus 1. Oh, where were you when I was teaching this to my grade 10s? Like, they really struggled this with. They really struggled with this. So how do we solve for this? What do we do now? We set each factor equal to 0. So we're going to have x equals 0, and we're going to have x minus 1 equals 0. So this will be x equals 1, right? Everybody there? Now we're going to sub back in. What did x equal up at the top? What did I say x was equal to? So we're going to say sine theta is equal to 0, and sine theta is equal to 1. And now we're going to solve it from here. So now we're back to 4.5. So this portion up here was 4.6. You do not have to, okay, so let's talk about some things before we go ahead and solve. If you are going to replace the trig function with a variable, you need to define that variable. You need to have this. This has to be there. Trick is you got to remember to put sine back in and then go ahead and solve there. Does that make sense to everybody? I have done this for a million years, and I'm okay with factoring with the sine in there. Like, I'm okay to go, oh, I know I got a common factor to sine. That's going to leave me with sine theta minus 1 equals 0. Like, I'm okay to do that, and I feel comfortable doing that. And if you're there, please feel free to do that as well. But for those of us who are seeing it for the first time or feel much more comfortable because we've got some solid grade 10 skills happening here, I'm okay that you do this too. This is a really good strategy to help with, okay? But you totally can do this as well, because this would be sine theta equals 0, and this would be sine theta minus 1 equals 0, so sine theta equals 1, which is the exact same thing you have down here. Does that make sense to everybody? So I'm okay with you doing it whatever way makes the most sense to you. Okay, now we're going to do the 4.5. What's our restriction? It's just one positive rotation. We'll start easy. So where is sine 0 on a positive rotation? Okay. So theta is equal to 0. And pi, and there's one more, 2 pi. Now did you notice I went back and I checked? My restriction does include 2 pi, and it does include 0, so I can include both those answers. Does that make sense to everybody what we did there? Okay, the left side has been taken care of. Now I got to go over and solve this one now. Pi over 2. Anywhere else? What is it when you're at 3 pi over 2? That's a negative 1, right? Because sine is the y values of the coordinates, right? So we're looking for where sine is positive 1. Definitely at pi over 2. But when I go down here, is it still a positive 1? No. So it's not that one. So my answers are 0, pi, 2 pi, pi over 2 for this question. Okay? Okay. And I answered that all on this sheet and not on the other sheet, so. Okay, let's do another easy one. Are we okay with easy restrictions, or do you want me to? Okay, let's make it harder. They are going to get harder with or without your permission, so it's better that we practice them hard, right? Correct. Sure. Okay, so this one freaks people out, and I'm not sure why. This is already given in factored form. This is already given in factored form. You don't actually have to do any math. Like here we had to common factor. Here you don't have to do anything. It's already factored for you. Yep. So we have sine theta plus 1 equals 0. And we have cos theta minus root 3 over 2 equals 0. So you're a step ahead of me, Basil. You did the moving already. But I'm just going to write this down just so we don't. So we're going to have sine theta equals a negative 1. And cos theta equals a positive root 3 over 2. Okay, we're not done yet. We still have to solve for theta. So that's the 4.6 part of the step. The 4.5 part of the step happens now where we're actually solving for the theta. So let's do the easy one first. Sine of negative 1. Where is sine negative 1? 3 pi over 2. Okay, that was my positive rotation. Where am I on my negative rotation? Negative pi over 2. Right? Because the only place that sine is negative 1 is right here. Right? On a positive rotation, that angle is 3 pi over 2. And if we're going to go backwards on a full rotation, we're still only going to have one answer. And it's going to be negative pi over 2. Again, you're finding that negative coterminal angle. Okay, cosine's a little bit more complicated because now we're not on an axis, now we're within the quadrant. So where is cos positive?
1 and 4.
Okay. So we have cos being positive in 1 and 4. So on our positive rotation, where is cos root 3 over 2? Ooh, should be pi over 6. And so if it's at pi over 6, where is that in quadrant 4? 11 pi over 6. Okay, so that's my positive rotation. So I'm just going to draw the pretty picture that goes with that. So I have 1 here, and I have 1 here. Okay, we're going to do a negative rotation. What? We did it for this side. Yeah, we did it for the negative pi over 2. Okay, so again, this is just your 4.5. So if we're doing the negative rotation, where's this one? So that one's my negative pi over 6. And this one's a negative 11 pi over 6. Now, Basil, you're doing this really quickly. Are you doing it visually or are you doing it coterminal angle in your brain? You're doing it visually?
Everything else I would do coterminal angle, but this is like easy to put in my
Okay. Okay, so this question has 6 answers. 6 answers. 1, 2, 3, 4, 5, 6. You need all of them to get this question correct. But you needed 4.5 to be able to do this.
I still don't get 4.5, but I get.
But if you can do this, then you can do 4.5.
4.5 is completely those ones that
Okay.
How many marks and what do you do on the test?
I don't remember.
Like 2?
Like 2. No, more than 2. Okay. This one. So example A is 4.5 again, because there's nothing we have to solve here. It's already factored. It's in the simplest form. It's given to us. So this is like 4.5. Okay, where is sine negative? 3 and 4.
Wait, why? 4.5 over finding like what's that called?
The reference thing?
Yeah.
We're going to do that again.
Oh, okay.
Yeah. So 3 and 4. I was writing and then I was trying to talk and it wasn't working for me. So as soon as I see this, it's quads 3 and 4, I need to find the reference angle. Because if I put this into my calculator, it's going to give me the single answer in quadrant 3. And then I have no way of solving for the quadrant 4 one. Like, so if you just pump this into your calculator, it's going to give you the answer for quadrant 3. But you're at a loss for how to get it to quadrant 4. So what we're going to do is we're going to find the reference angle. So sine theta of the reference angle, same decimal, it's just positive. Why what? Reference angles are never negative. Because if it's negative in your calculator, it's going to give you an obtuse angle.
So I can't put it negative?
If you put this in your calculator, it will give you the answer for quadrant 3 only. It won't give you the answer for quadrant 4, and you won't be able to math it out. Okay, so my calculator is going to be in radians. What? It's not in radians? And I have to use the second function button, right? So I'm doing sine. I feel like I'm yelling. Okay, so now what do I have to do? Well, yeah, because it continues on. And this isn't my final answer, so I'm not rounding it, right? Okay, so I'm going to do my rule for quadrant 3. Pi plus your reference angle, right? So in quadrant 3, ooh, that should be a 3. Rounding is hard.
So we can round these ones?
These ones because they are final answers.
Is that a 3?
That is a 3, sorry, yeah. I put a 2 and then there was a 5 and then I had to round and then I had to go back.
What's your restriction on this one? Because I had, so I had a hard time when it was like, say the restriction was like a positive 4 pi. I
Okay.
didn't know how to get
Your next rotation,
the next rotation.
add 2 pi to your answers.
That's what I did, and it didn't match up the answer key. And
It
then
should
I
have.
was so confused.
Well, let's look at that one because that's what you do. Your strategy's right. We just got to figure out if we went
Like, how did they have 6 answers or whatever?
Okay, okay, so then what's the rule for quadrant? So it's going to be 2 pi minus theta reference. And you guys are all using your pi button. So this one's going to be 6.1245. And am I going to have any other answers with that restriction? No, because my only answers would have been in quadrant 3 and quadrant 4. So this is an answer, this is an answer. Is that an answer? No. And I keep labeling it theta r to kind of get that point home that that's a reference angle. That's not a solution to this question. It's only an answer if it's quadrant 1. Yep, correct. Okay. Okay, this one is another 4.5 question. Do you want me to do this one or do you want to hop into this stuff? Yeah. Because my restriction is just one full rotation. Okay? But you're right, Danica, like if it was a different restriction, we'd have to stop, do our positive or negative coterminal angles that go with this. Okay, do you want to do B or do you want to skip to solving? Okay, skip to solving. Okay. Okay. This one has a little, this one, what do we feel about this one? No negatives in this one. Let's leave this one the way it is and then we'll make this one harder. Yep. Yes, I would do, and I do that division in my calculator first, and then that question just becomes part A. Right, because we don't have cosecant buttons on our calculators, so I'm going to do that flip right away. Okay, this one. No squareds. No squareds. So
You just solve it like standard.
just solve it like you're in grade 9. So I want to get all my coses to one side. Yes, do you want me to turn it into x? So let x equal cos theta this time. So this is going to be 1 plus 2x equals 5x. So what am I going to do here? I'm going to have minus 2x from both sides. 1 equals 3x. Divide by 3. Divide by 3. X is equal to 1/3. So cos theta is equal to 1/3. If you're okay with these ones, so I'm just going to minus 2 cos theta from both sides. And we're going to have 1 equals 3 cos theta, so 1/3 equals cos theta. Okay, cos theta is positive in quads 1 and 4. All right. My restrictions are in radians, thank goodness, so I don't have to keep switching back and forth in my calculator. So I'm going to do second function in my calculator, second function cos. I don't think you should have got 0.
That's in brackets, I think.
Yeah, the use of brackets is... Okay, so my answer in quadrant 1 is 1.2310. And what's my answer in quadrant 4? Okay, but let's look at this for a second. I just got excited. I saw the 2 pi. Let's look at that restriction. So we have an answer in quadrant 1 and we have an answer in quadrant 4. Where is my restriction? Theta has to be greater than pi, but less than 2 pi. So there's my like that's the only place my answers can be. So is this included? No. So that answer is gonzo. But did I need it? Yes, because I need it for my reference angle for quadrant 4. Look at your restriction. There's like it's not 0 to 2 pi, it's pi to 2 pi. So it's just that bottom half. So this one isn't included in our solution set. So quadrant 4, 2 pi plus theta reference. Now notice I didn't label this as theta reference because I was pumped that it was going to be in quadrant 1. Yep. This is what happens when I start talking and trying to do math at the same time. It's dangerous. Dangerous, I tell you. So my answer for quadrant 4 is 5.0522. And that is my only answer for this question based on that restriction. And that one I could see, like I obviously was going to screw it up because I was going to put my answer for quadrant 1. And remember, you can always erase it or cross it out or whatever, but it's good to check your restrictions before you get started. Okay, so Amber, as per your request, we're going to make this restriction nice and ugly. We're going to do, let's do a 4 pi rotation on the front. And let's do just a regular negative 2 pi on the back. Oh, yeah. Oh, yeah. No. No. No, no. I love you all, but no. Okay. I feel like this isn't dark enough. Okay. So what am I doing with this one? This one's nice and easy to solve for this one. Do I need to say let x equal or anything? I think this one's pretty straightforward. We're just going to divide out that 4, right? So sine theta is equal to a negative 1/4. So as soon as you see that negative, you're probably going to have reference angles, right?
Miss Kanye,
Yep.
could you say the restriction again? I'm blind.
Oh, sorry, and I put it in pink, and that's, so positive 4 pi, negative 2 pi.
Okay.
I changed the brightness on this, and it's washing out a few colors, so. Okay, so sine is negative in quadrants 3 and 4. So we are going to find our reference angle. And I keep putting sine to the negative 1 just to remind us that we have to use our second function button in our calculator. You do not have to write that step. I don't want you to feel like you have to. But if it helps cement it into memory, I would encourage you to keep doing that. Okay. Always when we're finding the reference angle. Always when we're finding the reference angle. Okay, so in quadrant 3, my rule is pi plus theta reference. So in this one, I'm going to have answers here and here. I don't like that pen either. I'm going through a pen crisis right now. Oops. So I'm going to get 3.3943.
Can we do a restriction in degrees after?
For sure. Yep. Okay, so that satisfies a full rotation, right?
Yeah.
That satisfies a full rotation. How many rotations do I have to do? 2 full rotations. So what am I going to do with these is I am going to make positive coterminal angles for them. So I'm going to add 2 pi to them. So I'm going to do this one first just because it's on my calculator. I'm going to add a full rotation to it. So I'm adding 2 pi. Yep. And I'm going to get 12.3137. Add 2 pi.
That's so easy, I was overthinking it.
And so I've got 3.3943 plus I'm going to, so I'm just doing coterminal angles, right? Like, oh geez.
That's an answer though, right?
Yeah. So 96775. Okay, so what you've just done is you have found your 4 answers for the positive rotation. Now we had twice around the circle, but those would be my 4 answers, right? Everybody agree? You hit 2 of them on the first round, and then you hit those 2 again on the second round. Okay, so now we got to do the negative rotation. So really, I'm going back to these first answers here, going back to the first answers, and what am I going to do with those? I'm subtracting 2 pi. So I got 3.3943, and I'm subtracting 2 pi. Okay, so this one would match that one there. And then and so again, make sure you're going back to that first set, because you'll have to do it twice. You added 2 pi, then you'll have to subtract 2 pi, then you'll have to subtract 2 pi again. You don't have time in your life for that. 6.0305 minus 2 pi. Hey, look at this one. So those are your answers for your negative rotation.
So wait, if the negative rotation was negative 4 pi, you would just subtract negative 4 pi from them?
You would just take 2 pi, like I would do them one by one. Like I would take 2 pi off these ones, yeah. Yeah. That's usually, well, because this in here, this angle in here, when we solve it for your reference angle, is the 0.2527, right, as your reference angle. But if I do it as a rotation, how far have you traveled in this direction? You've traveled in negative. Does that make sense? Kind of, sort of. And if I did this in my calculator, if I did second function sine of -1 divided by 4, I get, sorry, that's kind of hard to see. I get the exact same answer. So all it's going to give me is that one angle, when really I needed 6 answers to answer this question. Okay? Okay, what do we want to do with this one? We're going to make it degrees. No, I'm gonna be nasty. Okay, so the restrictions, Basil, just in case you can't see, -180, +540. Okay, you got a tan squared in there. So as soon as you see a squared, just like when you were learning how to factor, when you see that squared, you know you're going to either use the quadratic formula, which will still work, ladies and gentlemen, or factoring. Okay, y'all prefer factoring. I love it. Can somebody come tell my grade 10s that? Because they do not prefer factoring.
Wouldn't be x minus 2 and then square root of the entire thing?
What?
Theta minus 2 and then square root of the entire thing.
No, we got to factor it.
Really?
Yeah.
Oh, yeah, no, I'm wrong. Never mind. Okay.
So we're going to have,
This is a trinomial factor.
it is, so I'm going to have tan theta minus 1, tan theta minus 4 equals 0. Okay, just let's go here. So tan squared theta minus 5 tan theta plus 4 equals 0. So I'm going to say let x equal tan theta. So we're going to have x squared minus 5x plus 4 equals 0. Can you what are the factors of +4 that will add to a -5? -1 and -4. So 2 binomials start with x's. One's going to be -1, -4. And you guys know that you can't lose this equal sign, right? Like that equal sign has to stay. If it started in the equation, it has to go all the way through. So x equals 1, x equals 4. Are you guys okay that I skipped a step there? Yes. Okay, good. So then this would result back to tan theta equals 1 and tan theta equals 4.
Factoring is great. It should be just factoring. None of the other stuff. None of
None of the other stuff, yeah.
Can you cancel out the other one because it's asking you to?
Nope. Nope. It's not an exact value on the unit circle. It's not that you're canceling it out, it's just not a nice value that we've memorized from the unit circle. Tan can be greater than 1. Because root 3 is greater than 1. Like if you actually did the square root of 3, that's a value, that's an exact value on the unit circle at pi over 3.
If they're both positive, they'll be in the same quadrant.
Yes. Okay. Okay, you guys try it. You guys try it. I'm going to freeze the screen and I'm going to go back and I'm going to try to write it in my notes so they're all there. Don't forget about your funky restriction.
Tan is the worst.
And ladies and gentlemen, could you solve tan theta equals 1 without a calculator?
Yeah.
Yes, you can. Can you solve tan theta equals 4 without a calculator? No. But tan theta equals 1 is a value on the unit circle. Oh dear.
So tan is 1 would be, so you would have to have both side be 1 too, because
Ooh, what?
wouldn't you need an x value of 1 and a y value of 1 to get tan?
No, you need an x value and a y value to be the same thing.
Both would be
What's root 3 divided by root 3?
1.
So where on the unit circle are both the x value and the y value the exact same thing?
Where are they? Exact same thing.
Pi over 4s.
Oh, yeah, okay.
Okay, don't forget your restriction. I gave you a terrible one. Oh, and we're doing it in degrees, so don't forget to change your calculators. Whoa. Whoa. This has really, it's been a lot. I'm trying to add.
That's a lot of visualizing.
Yeah. It's not. Oh, what? I'm trying to do my best. Trying to do my best. I just left you I'm over here doing this in the air, trying to figure out where I am. I'm out. Yeah. See you later. I'm gone. Okay, I'm going to show you my first one.
No, wait.
Show it to me. Don't show it to me. Show it to me. Don't show it to me. I'm going to show you my tan equals 1.
I want to try at least one.
Okay.
Oh, you didn't even, okay, you just gave it the answer. Okay, I can look at that.
Well, because I just did them all counting.
I'm mapping it out.
Okay. So tan equals 1 occurs, tan is positive in quadrants 1 and 3. And I know for tan to equal 1, both values of x and y have to be the exact same thing, and the only place that occurs is with denominators of 4, if I'm in radians, because I can only think in radians when it comes to the unit circle. So I know that it happens, the first one in quadrant 4 is 45, and I know the one in quadrant 3 is 225.
Oh.
Yeah? Oh, I haven't even got the degree? I would say 4 decimal places. I know. Okay. So here's my exact values, right? So I went around 1 full time and got both of them. And then 540 is an extra half rotation. It's 360 plus 180. So I'm going around once and I hit 2. I'm going around once and I hit 2, and then I'm going to here. So what do I need for this one? This one was my 45, and this one was my 225. So I got both on the first rotation, and then in my positive direction I had another 180.
So many answers.
So I need a positive coterminal angle, which gave me my 405. Okay, now I'm doing the negative rotation, and the negative rotation is only a negative 180. So the negative 180 is going to hit this one here. So I need a negative coterminal angle of that one. And that's where I get the negative 135 from.
Okay, wait, can you say that again?
Okay, so I'm going backwards this time. Negative 180. So if I go backwards this time, which one do I hit? The 225. So how do I find this in negative? Just find a negative coterminal angle.
Okay, I did it mathy and I still got it right, so I'm happy.
Perfect. Like there's lots of ways to get there, and I was just doing it visually. And that's not a strong suit for me. I'd much rather math it out. Okay, so here we go for 4. We ready? Oh, she's already there. So where are our answers again? Quad 1 and 3, right? So we're going to do theta equals tan negative 1 of 4. I tell you, non-calculator is really the way to go. Oh, what do I need to be in my calculator though? Jeez Louise. Well, where's my first answer? In quadrant 1. Reference angles and angle measurements in quadrant 1 are the exact same thing. So I need it, and notice I didn't label this theta r. So it's going to be my first one. Okay. Second function, tan of 4 in degrees. So theta is going to be 75.9638 degrees. So that's my answer for quadrant 1. My answer for quadrant 3 is going to be 180 plus that. So plus 180. So 225.9638. So there's one answer. There's another answer. That is my first 360. So, just drawing circles at this time. So I know I'm still in quadrant 1, and I know I'm in quadrant 3. So I need to go around another 180 degrees in the positive direction. So I'm going to hit that one. So I need a positive coterminal. I need a positive coterminal angle for that point in quadrant 1. So that's going to be 75. Yep.
255 for.
Yep, it should be 255. I apologize. I just didn't write that down right. Thank you. Plus 360. So that's going to be 435.9638. And do you have your degree symbol on your page? Okay, so those are all my positive ones. Now I'm going to do my negative rotation. And my negative rotation is only 180 in the opposite direction. So I need to find a negative coterminal angle for that one. Oh, you can't even read that. Can't even read that. So you need a negative coterminal angle at the 255 one. Yeah. degrees. Okay, so I had 4 on this side, and I have 4 on this side. So I had 8 answers for this question.
Awful.
Was it terrible though? It just takes a long time, and you got to actually like stop and make sure you're getting all the steps as you go. All right. Okay, more stuff. More stuff. Okay. All right.
Oh, is that like the K element?
Yes.
Okay.
Okay, we're revisiting this. Okay, so general solutions. General solution. We already did these. We already did these. And what does this mean? We're adding 2 pi, and k is an integer. We're going positive once, we're going positive 40, or we're going negative 300. So k is an element of the integers. So full rotation, however many times k is required. But they have to be, k has to be an integer because you can't have decimals. You can't have half rotations, right? Coterminal angles, we're always either adding or subtracting 2 pi. Okay, general solution for cos x equals 1. Okay, where's cos 1, people?
Oh, when X is 1.
Okay, so we're going to have x is equal to, so where's the first time we see that angle? So 0 plus 2 pi k, where k is an element of the integers.
How do we know if it's in radians or degrees?
That's a good question. I'll tell you. I didn't in this one,
Okay.
but I'm going to go with radians, but I should tell you. Yeah, exactly. Yeah. You will also see this one. I'm going to write the or option. You'll also see this one written like this. Because 0 has no impact on it. Because k could be 0, and you'd be at 0. K could be 1, and you'd be at 2 pi. K could be 2, and you'd be at 4 pi, right? Like, so it's just because of the 0 in this one. So that one's a little bit different. Okay, next one. Let's do this one in degrees. Because we need to be able to flip back and forth, because I'm going to ask you to flip back and forth. So it's good that your examples show the back and forth. Okay, general solution. So sine is 1/2. So we know our answers are going to be in quad 1 and 2.
Yeah, I don't.
Oh, yeah, okay. Amber's saying pi over 6. I'm writing it down because we think in radians, but we are doing this one in degrees. So 30 degrees. And then 150 degrees, right? So we are going to do, you have to do a general solution for both of those answers. Because if I add 2 pi k, where k is an element of the integers, why is it 2 pi? It's not 2 pi. It's 360. This is why we have to practice. If I add 360 to 30, do I get to 150? No, they're unique, so you have to treat them uniquely. I'm going to do this one right. And that's it. That's it for your general solutions. That's the answer. But you need to list both of them. If you only list one, you won't be fully correct.
The calculator one is easier.
What?
Yeah. I can't visualize it. I have a hard time doing it. Yeah, calculator so much easier.
Okay, let's do this one in degrees since we're on a roll. Well, I'm trying my best. Okay, this one.
Whoa.
So let's solve for secant first. So secant x equals 6 divided by 2. So secant x equals 3.
So 1/3?
So cos x is equal to
So what is close to that?
I just
6 elements, x 1/3.
I just divided out the 2. Okay, be wary, ladies and gentlemen, of the variables you pick. Notice this one has x in it. This one has x, so you can't say let x equal secant x. You got to pick a different variable, pick z or something like that. Notice this one's in degrees, so my variable started with degrees. At least I did that right today. Okay, calculator. So where's cosine positive? So quadrants 1 and 4, right? Quadrants 1 and 4. So x is equal to cos -1 of 1/3. Is my calculator in degrees? Yes, it's in degrees. So my first one is 70.5288 degrees. So that's in quadrant 1. What's my answer for quadrant 4? Okay.
So 360 minus that.
Mm-hmm.
Yeah, see, it's so much easier with a calculator, wow.
289.
Okay. So you have both of them. Now what are you going to do with them if we're making a general solution? Plus 360 degree k, where k is an element of the integers, plus 360k, where k is an element of the integers. Nice thing about general solutions is you're going to find the two places on one full rotation, and then you're just going to slap that on.